current will be moving, right? R direction means which view the side which you have taken, whether it's clockwise, anti-clockwise, or depending on that. So some circuits are read. I think we won't be needing this. Kirchhoff's law and all, we shouldn't need it because this is a very lengthy procedure. Try to reduce your circuits as many times as you can. Let me give you a circuit, a very easy circuit I'll start with. You should answer quickly. This question which I'm going to write right now, this is not telling you how accurate your answer is. So don't waste your time in the accuracy. Try to improve your speed upon this question because the values are also very easy, and whoever gets the correct answer, send me, because this is not an option one, so that I would be providing you an option. All right, so now the circuit, I'll draw it by myself. You will start it, note it down, and send me the answer. See class, again I'm telling you, just fill in the blanks type. One word answer one. Not options won't be given to you. Let me discuss it now then. Marita and Ashrit only have answered. Marita, you're telling me the current.
Okay, ma'am. Sorry.
Just try it again. Current is right. Current, no, I think you have reached your answer. This current is right. Now see, I think you'll take a minute time. Yes, Adriel, right answer. Just take a minute time, I'll discuss it then.
Ma'am, now we just have to multiply it with the voltage, sorry, resistance, right?
After your current, yes, yes. Priyadarshini, your answer is also right. Marita, correct answer. Now, voltage you have answered correctly. Ashit, see, current is incorrect. Current which you're getting, no, there's the calculation error. I think you must have committed. That's why you're getting this. Let me discuss this. All those who are having issues. When we'll resolve this, both are parallel. So 4 into 4 divided by 4 plus 4, directly I can write it as 2. And no need to even do this parallel calculation. Whenever two resistors are connected in parallel and they are identical, divided by the number of resistors present. If 3 4 ohm resistors would have been present, I would have written 4 by 3. Since 2 are present, so 4 by 2, like this. No, Krishna. I think same thing. Error in your current. So this part is 2 ohms. Similarly, this part also. When I'll resolve this part will be 4 ohm. This part, this is going to be 6 ohms. And when this is resolved, 15 into 10 by 15 plus 10 by 15 plus 10. So this is going to be 6 ohms, right? 6 per 10. Yes, this is going to be 6 ohms. Now see, in between this, 2 ohms is left. Let's say, let's take a point, say, let's say I1 current is moving. Let's divide at least the current so that we are clear with what we are calculating, I1. And let's say in this branch, we are having I2. This is I2. Now, you know how to calculate in parallel and series. So finally, equivalent resistor will be what? 2, 2, 6. They'll be added up. So 4 plus 6, that is 10. And here also 4 plus 6, that is 10. So then 10 and 10 parallel. Do you get this? C class. 2 ohm circuit. Now this 2 ohms, this 2 ohms, and this 6 ohm. One resistor of 10 ohm. 4 ohms, 6 ohms. Another resistor of 10 ohm. So their equivalent resistance, this is going to be 5 ohm. There, this circuits, right? Their equivalent resistance is going to be 5 ohm. Now you have one more resistor connected. So now what is the total resistance? One you will add to this 5, that is going to become 6 ohm. Right. Now see, if you take the current division rule also, if you take. So in the upper branch, how much current will be received? In the lower branch, how much current will be received? The current which you had calculated, no, Ashrit, you got no current, I think as 1 amperes only. That is not across just the 15 ohm resistor. You have to find, the question was asking you to tell about only about the 15 ohm. That way you are right. Even if we apply the current rule, so current 1, I1 in the upper branch, what will it be? 4 plus 6 is 4 is there and 6 is there, right? And in the denominator, you can directly write it as 20. 10 plus 10, right? 10 plus 10. So what it's going to be? This is, if you write current one, that is current into total current multiplied by the potential. If you write it in this way, in the current, in a current of the upper branch, so you can directly write it as I into 10 by 20, right? You can write this as I is equal to 10 by 20, or directly half, right?
Ma'am, can you repeat this again? Like how 4 plus 6 by 10?
See, just apply currents. This is the upper branch, right? So voltage across this branch is equal to voltage across this branch, because both are equal, right? So how will you write voltage? How do you write voltage? Voltage is equal to IR. So current in the upper branch is I1, current in the lower branch is I2, resistance across the upper branch is 10 ohm, resistance across the lower branch, just this part, is also 10 ohm. 2 minutes for, okay, fine, take 2 minutes. If you think you will reach the answer, then okay, take 2 minutes. Faster method. See, faster method. No, if I suggest you all the faster method, had I got this question in my entrance, what would have I done? 12 ohm, 12 volt is the total voltage, right? 12 volt is the total voltage. Those what? Obviously, all of you want to try it by a faster method. This I would suggest you. Total voltage is 12. Total resistance is 6. What is the total current? Total current. So voltage you have 2, right? 2 amperes it's going to be. So in the branch which is required for you, like you were getting 1 ohm, so directly you can, if 2 ohms is entering and both the branches are having the same resistance, right? This is also having 10 ohm, this is also having 10 ohm. That means current which is divided is identical. So 1 ohm current will be received in each. If I want to draw the circuit, I'll draw. Let me draw and tell you. 4 ohm, 6 ohm. Here I am having 10 ohms. This is 12 volt. 1 ohm was here, right? So it's like from here, let's say I total, this is 2 amperes. So here this is receiving 1 ampere, here this is receiving 1 ampere, right? Or let's break 6 ohms. Directly let's bring 15 ohm into our answer. Let's do one thing. So till now this is clear. how much of current will this branch receive? This part. This will receive 1 ampere. All of you agree with this, right? 1 ampere will be received. So this part of the circuit will receive 1 ampere. Now class, what was 6 ohm? How was 6 ohm obtained? 15 and 10. It means that part of the circuit is 15 ohms and 10 ohm. This was what earlier? This was only 16 ohm, which was having current 1 ampere. What is the potential across this part? Potential across this part will be 6 into 1, that is 6 volt. So these are in parallel across 15 ohm or 10 ohm. What will be the potential? It will still be 6 volt. Had it been connected in series, then this wouldn't have been the answer. But I think Adriel was also asking the same thing. This would be the fastest method. You don't even need to solve it. Solve in your question paper directly. Try to figure out all the parallel component. Just check whether they are identical or not. Both the branches are identical. Calculate the total current in the circuit. So once you have the total current in the circuit, this is how your circuit looks like now. So across this branch also 1 ampere, across this branch also 1 ampere. Across this branch, this will be 10 volt, right? Across this part, it is going to be 4 volt. Across this part, this is going to be 6 volt because current is only 1 ampere. So once you have 6 volt, if the two circuits, if the two resistors, they are connected in parallel, both will be having the same potential. So directly also you all can get your answer as 6 volt. Clear to all of you?
Yes, ma'am.
Yes.
Okay, note it down. I'll give some other circuits. So till now, only Krishna and Merita have answered correctly. Others, I'm waiting. Then I'll discuss it. It's just a one thing you have to identify in this circuit. Your answer will come very quickly. So yes, most of you have answered this correctly. See, those who aren't able to do. 5 ohm resistor. This is short circuited. Look here. This is short circuited. So this is not in your circuit. Your circuit is this. This rest part is your circuit. Fine, this is not part of your circuit now. This is short circuit. It is just acting as a simple wire. Instead of this 5 ohm, you can replace it with replace this by a single wire. Now look here. 2 ohm and this 2 ohm. They are connected in parallel. So 2 and 2, that will become 1 ohm, right? Now this 1 ohm, which is present, this 1 ohm and this 2 ohm, I'll make a separate diagram. I'll make a separate figure. See, now what it's like, it's 1 ohm here, there is reduced circuit. Now this is 2 ohm was left, 3 ohm, 3 ohm, A and B. Now see, 1 and 2, they are connected in series. So this becomes 3 ohm. Now this 3 ohm with these 3 ohm, they are connected in parallel. So 3 ohm divided by 3 gives you 1 ohm. Why divided by 3? Whenever you have identical, I'm repeating this for the second time, whenever you are having identical resistors, in parallel, then divide the magnitude by number of resistor present. That's it. So D option is right. Noted down. So Priyadarshini and Adriel have answered. Others, last 2 minutes and I'll discuss it. Check these arrangements, put on these arrangements and see, are you getting 46/3 or not? No, Marita. See, just check the fourth option. D option is the right answer. So I think Adriel and Priyadarshini only have answered. Just set up it 2 and 4 parallel along with 6 and 8 connected in series. You'll get it as 46/3. Look, if this is 2 ohms, this is 4 ohms, this is 6 ohm, this is 8 ohm. Actually, you have to check for all the options since I know the answer that is D. So I'm directly writing it down because by the other options it won't come. Now you take out equivalent resistance. 2 and 4 in parallel. So that is going to be 2 into 4 by 2 plus 4 plus 6 plus 8. This will turn out to be, this is 14. So 8 by 6. This will come out to be 46/3 when you will reduce it. So D option. Why only 2 students were able to answer this? This was the easiest question. And this was from your previous year only, this question. So only Adriel and Marita have answered correctly. Yes, answer is 10 ohms. Look class. In the given figure, switches S1 and S2 are in open condition. Resistance across AB when the switches are closed. If they are closed, what will happen? All will be in parallel. So this in parallel, along with this in parallel. Like this, you just have to, in these questions, no, these types of questions look very lengthy, but their calculation part, especially the circuits part, is not very difficult. See, how will you write the equivalent resistance? This will become 12 into 6 by 12 plus 6. This will become 2, 4 by 2. This will also be same thing, 6 into 12 by 6 plus 12. So 6 into 12 by 12 plus 6 is 18, 72. So 72 by 18 plus 2 plus 72 by 18. This becomes 4 plus 2 plus 4, 10 ohms. That's it. Some more questions, let us practice. 2 to 3 at least. Yes, last 2 minutes. Marita has only answered and her answer is correct. Others also try this at least. See, correct answer, all those who have submitted, it's only Marita and Adriel. Again, Adriel and Marita, their answer is correct. Others have at least tried it. Krishna, Priyadarshini, Ashwin. Okay, see, at least you all have attempted the question. Those who aren't attempting, it will be their loss. Because after attempting the question, once you listen to the solution, then it becomes a little more easier. See, I'll draw this in a simplified manner. Then tell me whether you're able to solve this or not. This is 1.5. Fine. 6 and 2, these two are in parallel only, so I'll draw them in parallel. Rio. And this is 6. Now see, 1.5 is here, right? This is 1.5. And this will be 6 into 2 plus it. This will also be 1.5. So instead of this, I will write it as 1.5 ohms. So 1.5, 1.5 in series. This will become 3 ohm. And this is itself 3 ohm. Right. This is itself 3 ohm. So 3 ohm in parallel. Yes, I'll explain. Just a minute, Ashit. So they are in parallel. So R equivalent, this becomes 1.5 ohms. Right. Now you have to find out current. So voltage is 6. Equivalent resistance is 1.5. So 60 by 15, that is 4 amperes. C option directly. Now let me explain you the figure. See, suppose if I take this circuit, it's like when you, this is along with this 2 ohm, 6 ohm, 3 ohm, they are connected, right? If you pull this, if you pull it from this part, how to get this reduced circuit? See, if it's like, if you pull it from this part, you will see them in parallel, right? 6 and 2. And what will happen? If 1.5 is already connected in series, this and they become parallel to each other and they become parallel to each other. Whenever you're having no questions from circle, so in questions from circle, even if you're getting 4 figures like this, such type of figures if you get, where four figures are given, even if you just pull it from here, so what will happen? This, they'll become parallel. So out of it, if they are parallel, I have removed this wire. So what happens? Now their resultant becomes in series with this. And now since this is added, this is also in parallel. So that's how this reduced circuit, I've drawn it just for the ease. Otherwise, you can perform your calculation within this circuit as well. Note it down.
But ma'am, 1.5 is in series with the other two, right? But you said it will be parallel.
Yes. See, if had there been a wire, that would have been connecting. Right. See, if there were no 4 thing, let me show you. Wait. See here, for this circuit, this is our circuit that we have, right? Now, if suppose this was given to you, no, this case, if this example was given to you, then you would see all these 4 are, they are connected in parallel. Now see, if you go by the potential divider method, right? This This is directly obvious that this is in parallel. Here what is happening, it's like, I'll show you, or it's better instead of this, no, just look at by this circuit. They are in parallel. This is the curved wire, I straighten it this side. And this is the edge with which they were connected. This is that edge, fine. Then 15 ohms wire is passing straight. It's like this part is there, right? This part and this part is there, which is having this wire and this wire. So this is the same thing which has been drawn. Instead of like this, the wire is bent and this is drawn like this. Same thing, no? This edge becomes this edge. This edge, it's like one breakage I have kept it here. That is straight. So look, this is 2 ohms, 6 ohm with this. So this 3 ohm part goes to this 3 ohm and this other part that extends to the battery. That is the same thing. And here this gets extended. That is 1.51 with a single wire, right? This gets extended with a single wire. So that is 1.5. And now that is connected along with 3 ohm. So 3 ohm is connected across 6 and 1.5. So this portion, instead of this portion, this is like 1.5 part here, entire 6 ohm part here. And it's like this is your 3 ohm. So instead of it, you can just draw it and make it bent into a form of proper straight wires. That's it. But more than that, if you are getting, I was saying about this, yes, if you're getting this part, if you get such type of question, no, where battery is not mentioned, right? Battery is connected along with it, the way it is connected. Make all the 4 R1, R2, R3, R4 all in parallel, direct. All in parallel. But if one is connected, you have to check where the battery is. Like here, 6 volt interrupted it, right? 2 ohms and 1.5 ohms, 6 ohm, 3 ohm, all were there. It was interrupted by battery. Had it been if you remove these ends of it, right? If you remove these ends, then the case would have been something else. Now what is happening? This, there isn't, if there is any interruption with the battery, then again, this becomes, because the wire, the basically the potential starts getting divided. So that's how you have to check. Okay, all those who have completed, you can leave. Now we are left with magnetics only, that will complete in the weekend. All right, thank you so much.
Thank you, ma'am. Thank you, ma'am.